Last video for lesson 29, looking at summation notation in this video. Now, there's another name for summation notation, okay, and that's generally what we refer to as a series. Now, what is summation notation? It's this giant E-looking thing. You've seen it before in Algebra 2, okay, maybe not heavily, maybe not much, but we're going to go ahead and keep it in mind now. Look at this notation. It says, and I'm going to go ahead and zoom in on it so you can see it a little bit better. This is the sum of I equals 1, starting at 1, going to n, of the sequence a sub n. Okay? Notice the sequence a sub n. It's very important that you understand that a sub n is a sequence. It's a list of terms. What does the sum do? What is the sigma? That's the Greek letter sigma, that E-looking thing. Okay. What does the summation notation do? It adds them all up. First term, second term, third term, so on and so forth until I hit the nth term, and then I add them all up. Okay. Now maybe we probably shouldn't have used n here. Maybe I should have used, and actually it should have been something else. It should be I. Let me change this here. This should be a sub I. Okay, and I'm replacing all of my i's with 1, and then 2, and then 3, and then 4, until I've reached this number n. 1, 2, 3, and so on and so forth until I've reached the number n. Okay. Now again, let's look at definition 13 before I move on to the last piece. Again, this sum is a sequence. The sum of a sequence. Again, the sum of a sequence. This is the sequence, a sub I, okay, and we're adding up all those terms. This is called a series. A finite series is one that has a finite number of terms. Ends at a certain value n. Okay, ends at a certain value n. The I in this is called the index of it. Okay, it's the term, the thing that I have inside of the actual sequence, and it's the things that I'm plugging my numbers into. Okay, n is the upper limit. I equals 1 is the lower limit. Okay, it's the starting point and the ending point. Start, end, the thing that I'm plugging it into. Okay, so let's look at example 14a. I've written it on this separate piece of paper. Now, this is, and I'm going to read it again so you understand what I'm trying to talk about here. This is the sum from 1 to 4 of I divided by I plus 1. What is this really? Well, this is actually very, very simple. Okay, just be careful with what you're doing. This is going to be equal to, I want to plug in 1 into this thing. When I plug in 1, I get 1 divided by 1 plus 1. The next thing I want to do is plug in 2. Why 2? Well, because it's the next number after 1, so plus. What happens when I plug in 2? Well, I get 2 divided by 2 plus 1. Now what happens when I plug in 3? Why? Because 3 is the next number, so when I plug in 3, I get 3 over 3 plus 1. And now I'm going to plug in 4. Why am I going to plug in 4? Because that's the next number. When is it that I stop? Again, starting number, the first number I'm going to plug in. The ending number is the last number that I plug in. I've plugged in 1. I've plugged in 2. I've plugged in 3. I've plugged in the number 4. Once I've plugged in the number 4, I stop. I add up these 4 terms. Okay? So this is 1/2 plus 2/3 plus 3/4 plus 4/5, and whatever those numbers added up together is your answer. Again, I'm not worried about you being able to do that in your head. Type it in the calculator, honestly. Okay? So whatever that number is your final answer for that. Let's talk about the next one. 14b is the summation as j equals 2 to 5, -1 to the power of j, j squared. Okay, I'm going to go ahead and put that in parentheses, so I'm very careful with this. Notice, where am I starting? Starting at the value of 2, where do I end at the value of 5? Does that mean I have 5 terms? No. Yes, I did have 4 terms up here, but that was because I started at 1, and when I plug in 1, 2, 3, 4, I have 4 terms. But when I plug in 2 to start, 2, 3, 4, 5, I actually have 4 terms. Okay. Now very carefully, let's plug these numbers in. I'm going to plug in 2 first. Again, I plug in 2 because that's my starting point. Negative 1 to the power of 2. 2 to the power of 2. Notice this time I'm plugging it in for j because that is my index. Wherever I see a j, that's what I'm plugging in. That 2 value. Okay? That's the first term. Adding to that again, because this is a sum. This is the sum of all these terms. Let me plug in 3 now. I have a negative 1 to the power of 3, because it's negative 1 to the power of j, and then times 3 to the power of 2. Plus, we do 4 next. Negative 1 to the power of 4 times 4 to the power of 2. Lastly, one more term. Why one more term? Not because I'm looking for 4 or 5 terms, because I'm looking for me plugging in the number 5. Once I've plugged in every number up to the number 5, I know I'm done. I plugged in 2, then 3, then 4, then 5. Starting at 2, ending at 5. And then I evaluate all these numbers. Now this is actually going to be a lot easier than you think, possibly. This is a positive 1, this is 4, so that's 4. Minus, because this is negative 1 to the power of 3, that's a negative number, and 3 squared is going to be 9. Positive, because it's going to be negative 1 to the power of 4. Wait a second. Positive, negative, positive, negative. Isn't this an alternating sequence? Wait, not alternating sequence, because this is a sum. This is a series. This would be considered an alternating series. Okay? Keep that definition in mind. So you have 4, negative 9. This one here becomes a positive, and then 4 squared is 16. And this one here is going to be a negative 25. I add all those numbers up, okay, or subtract them appropriately, and I'm done. This becomes negative 5. This one here becomes a negative 9. Negative 9 plus negative 5 is a negative 16. No, 14. Again, check that math on there, just in case. This is negative 34 together, and this is 20, so yes, negative 14. That completes those ones. Now, I'm going to look at this last piece of properties. Now, it says try to explain these properties in words. I'm going to go ahead and do that for you. Okay? This is the summation of I equals 1 to n of one sequence plus or minus another sequence. But if I have 2 sequences and I'm adding them together or subtracting them in a series, in a sum, it's really the same thing as taking 2 separate sequences in 2 separate sums and adding them or subtracting them. Okay? It's just moving the terms around. Again, it's just moving the terms around. I happen to put all the first terms over here in this sum, and then I'm going to add or subtract that to all the secondary terms over here. Okay? Let's look at this one right here. This is the sum as I equals 1 to n of some c value. Now, c is supposed to be a constant number. Doesn't change at all. So let's just say it's like 7. 7 times the sequence a sub I. What does this say? This says I can pull out that c value. I can pull the c value out of there. Which means that any constant that's being multiplied by the sum, as long as it does not include the index, that I, that little I right there, as long as it doesn't include that I, okay, here or here, I can pull that c out of the sum. Okay, that number out of the sum. Lastly, when I'm looking at the sum of just a constant, and it's going from 1 to n, not 2 to n, 1 to n, then it's just n times that c. It's just the number of terms that I'm going to have times that constant. That finishes our notes for 29. We will be playing with these things a lot more in the next videos. Okay, so in lesson 30 and lesson 31, we will be returning to those concepts and we'll be revisiting them in a little bit more depth with a little bit more definitions.